That works. Okay. Well, now it works. So we are just going to start working our way through some of these. Okay. I've got an answer key floating around right here. How many people were able to get through 1 through 4 right already? Okay. And we'll talk through them real briefly. Why is number 1 a really easy one to do? Saeed.
Because they cancel each other out.
They cancel each other out. Do you, anybody remember the official name for that? Probably not. It's okay if you don't. If they cancel each other out, they're called additive inverses. They're called additive inverses. So these are additive inverses, which means exactly what you said. They cancel each other out. They're opposites. So we didn't even need to do any work on that one. Number 2, what do we got? What should we be remembering for number 2? Good. Different sign subtract. We keep the sign of the bigger one so that you can be exact. What? So the bigger one is negative, so our answer is going to be negative, and we add them together. 2.7, 7.5. Remember, when we add decimals, what do we need to do? We need to line them up, right? So we know it's going to be negative. So we need to add them up. We get 12. 1, 2, 3, 4, 5, 7, 10.2. With me on that? Remember, I'm going through these first 4 pretty quickly because many of you have already done them. Now we're going to find the difference. But is number 3 really a subtraction problem? No, you guys remember what we would do a lot of times with these? Not Negative Ninja on this one. I love your idea. Negative Ninja is not on number 3. Negative Ninja will be on number 4. But I use the circle method when we did these. So we could see this isn't a subtraction problem. This is just 2 negatives. Yeah? This is just same sign add, isn't it? So, and luckily for us, why is this luckily? Yeah. Which means we can just go ahead and add them. We can't add or subtract fractions that have unlike denominators, but these already have like denominators. So it's kind of nice for us. So we just add them. We get 11 over 3. Both of those are negative, right? And that simplifies. 3 goes into 11 how many times? 3 times with the remainder of 2. And it's going to be negative. Why is it negative? Same sign add, different signs. We keep the sign of the bigger one, which is negative. Remember, that part of the wrap works for every single addition or subtraction problem. Number 4. Here we go, Tori. What do we got going on here? Height! Negative Ninja. This isn't a subtraction problem. I love it when subtraction turns into addition because I hate subtraction. I'm bad at it. I'm not very good at it. I mess things up. I forget to carry the 1. Like, what is this whole carry thing, man? If I can change it to addition, nice. It's a lot easier. A lot easier. So I just make sure I line up the decimals, right? 2.4. I bet many of you guys could do this one in your head without lining them up. 11.89, right? So we did those first 4. All right, at 1 p.m., the total snowfall is 3 centimeters. At 4 p.m., the total snowfall is 8 centimeters. What is the mean hourly snowfall? It's a little tough to think through what it's asking for here. Does snow fall at the same rate all the time throughout that time? But what it's asking you to do, when it's asking for the mean hourly snowfall, what that's asking for is how much did it snow on average throughout that time. So this is a division problem. Okay? First we need to subtract and then we need to divide. So Darius, what do we think you need to do on this one? It's a what do you think question, so I don't care if you're wrong. It's a what do you think question. So I just want you to get our brains thinking, get it started. What does it mean by hourly snowfall? If I asked you what is your hourly wage at your job, what would that mean?
How much you get paid per hour?
How much you get paid per hour. Hey, did you hear those words? Paid per hour. So hourly snowfall, Darius, what does that mean? Snowfall per hour. When it has those words, when we think snowfall per hour, we should be able to set up what kind of relationship? Not a proportion. I love that you're thinking that though. That's awesome. It's a division problem. It's a division. It's a ratio comparing two things using division. Snowfall per hour. What's the snowfall? Saeed?
I'll put 3/1.
3/1. Okay, I like the idea.
And then 8/4.
8/4. Okay, I like that you're thinking proportionally. Unfortunately, this is not a proportional relationship. All right, so I love that you guys are thinking proportionally. We talked about proportions yesterday. We talked about those relationships yesterday. That's good that that's on your brain. This, unfortunately, is not a proportional relationship. We're looking for the total snowfall. Okay. Yeah.
Would you subtract 4 minus 1 and then do 8 minus 3 to figure out
Yep. So the idea here is that at 1 p.m. it's at 3 centimeters. At 8 p.m. At 4 p.m. it's 8 centimeters. So what was the snowfall? Well, it was at 8 centimeters at the end, but it started at 3 centimeters. So that would be 5, right? What was the hourly difference?
3 hours?
3 hours. So 4 minus 1 gives us 3. Now why am I not adding 3 plus 8? Shouldn't it be, isn't that how much it is?
No, because 3 is your start time and 8 is like
Your end time. It's saying the total snowfall at 1 p.m. is 3 centimeters. That's how much it was at already. And then at 4 p.m. the total snowfall is 8 centimeters. So now we're at 5/3. So the mean hourly snowfall,
is
1 2/3. We call it centimeters per hour. 1 2/3 centimeters per hour. So it's a tougher question. That's kind of like slope. It's tough. That's not an easy one. I'll let you guys do number 6 on your own. I bet you can do it. Give you a second. Ready, set, go. How many people are able to do it in your head? Because what is this actually asking? This says 19/2, but another way to think about that is what? 19 halves. Half of 19, right? When you divide something, when you divide something by 2, it's taking half of it. So what's half of 20? What's half of 18? What's half of 19? 9.5. All right, I want you and the people around you to do number 7 through 10 together. Talk about them with one another. I'll give you, how much time do you think on those 4? 6 minutes? 5 minutes? Shouldn't take too much longer than that. 5 or 6? 5 or 6 minutes. Time to pause. All right, there's the first 2. Ready to check? Don't forget to sing the song whenever you're multiplying or dividing. Number 10 is a lengthy problem. It will take you some time. and 10. So double check your signs. 7 is positive, 8, 9, and 10 are going to be negative. Why? Same sign positive, different sign negative, right? So same sign, different sign, different sign, different sign. Right away I decide what my answers are going to be, the sign of my answers. Don't wait on the symbols, don't wait on your signs, because you're going to make them positive on accident. If you decide on your sign right away, you probably set yourself up for some more success. Now we did a problem like number 11 on our quick quad, right? So, can we do number 11? Someone walk us through it. I want a person volunteer. Jory, walk us through what we should do.
So basically, so right off the problem, like, so negative 9 over 5, so that's negative 9 over 5, and then times 5 of the reciprocal of the second fraction would be 5 over 1.
Nice.
And then, so that's the key tables for the part, and then that would equal negative 45 over 5 since it's, because you have to keep it as a negative sign.
Hold on, ladies. I can't hear. I'm sorry.
The answer would be negative 9 since you have to keep it.
Good. I like that. That's cool. Anybody, when you do this problem, anybody recognize the cross canceling that you can do? Recognize the 5s and the 5s? So we could have actually gone straight from this, cross cancel those 5s, 1 and 1. Instead of 45, we could have actually gone straight to the 9 as well. 1 and 1. We could have gone straight to here. But notice that Jordan reminded us that it's going to be negative because different sign negative. Okay? All right, we're on to the back. Look at that. We're on to the back. Now, I'm saying do this one without a calculator. What do we need to find? What does it say to do?
Find the mean.
Find the mean. Someone tell our class what it means to find the mean. Anna.
You add up all of like the numbers, like the data, and then you divide by them.
And divide by how many there are. So how many are there?
6.
How many?
7. 8. 6.
So counting is going to be an issue.
8.
There are 8. Careful, that -1 is a -1. All right, it's not -1, comma, -1, 2.25. So here's the deal. We need to be able to do this one without a calculator, and you can. So we need to be strategic about how we add. I want you to look at the numbers and look at which 2 you should add first. Keeping in mind that addition is commutative, meaning with addition we can change the order, right? We don't have to add left to right when we're adding. We can add any of those 2 numbers together first. So which of these 2 should we add first? Look on your paper and decide which 2 you should be adding first. And there is a correct answer to this one. Let me change that statement. Which of these 2 will be the easiest to add together? Anna.
-1 and -4.
That's cool. I like that. Those would be the second easiest in my opinion. I like those 2, -1 and -4. That gives me -5. Okay, I'm down with that. But there are 2 that are even easier than that to add. Ashley,
-2.5 and 2.25.
say again.
-2.25 plus 2.25.
These 2, ones I just circled in red. Why are those the easiest 2 to add? Luke? Yeah, they're called additive inverses. So they are 0.
So is -4.75 and 4.75.
Ah, you see any others? Did you see that one? Did you hear that? -4.75. I'm going to use a different color actually so it's easier to see. -4.75 and 4.75, meaning that those 2 will also equal 0. So, if you are strategic about your adding, this problem is a lot easier, isn't it? And now let's add the last 2 numbers, 2.75 and 0.25, which are also pretty easy to add, right? If we're strategic about it. Those 2 are going to be 3. So now, we've done all this work, plus, plus, plus. We can add all those together. 3, 0, -5, and 0 gives me a grand total of -2. Why? Same sign, add. Different signs, subtract. We keep the sign of the bigger one, which is negative, so we can be exact.
What?
Thank you. All right, so that is not our answer though. We need to divide by 8. -2 divided by 8 equals -4. Excuse me, not -4. What am I saying? Negative what? Oh, come on, guys. -2 divided by 8. Negative what? Nope. Come on, guys. This is a fraction. Just simplify it. -1/4. Or -2, -0.25, right? It's a quarter. So the reason why I did that one together is because I wanted you to recognize that this problem is doable. We need to be strategic about it though, right? Strategic about which numbers we add first. So don't just start adding things. If you have a problem like this on a no calculator portion, which is what we're doing today, we're doing no calculator today, and on the rest of your homework today will be no calculator. If we're doing no calculator, then, well, we need to be strategic to make our life easier. Yeah, we could have added these across, and you would have gotten -2. This problem would have been a lot more tedious, a lot longer, it would have taken a lot more effort. So be strategic about it, okay? We're gonna start number 13, but I wanna get down to number 15, okay? Why did I circle those?
The X.
What do we call those? Ooh, what are these things called? They are called what? All of them are called? No. Some of them have X's with them. Are called terms.
Oh my god.
So then why did I circle those and box the other ones?
They're like
Because they are like terms. What can we combine?
terms.
What can we not combine?
Unlike.
Unlike terms, right? So we can only combine like terms. I'm trying to remind you about the circle method or the shape method that we did. 5/6 and -1/2. Well, to do this one, we probably are going to want to probably want to get them to be common denominators. So 5/6 x minus 3/6 x, which gives us what? No, 2/6 x. And then the -11 and the -11 gives us -22. So that whole thing will simplify to what?
-1/3 x minus 20, -20.
So it's not negative. It's going to be positive. Only because if I keep change flip, the smaller one is negative, the larger one is positive. This one's tricky. This one's a tricky one. But there will be some of you that will be able to be doing these kinds of problems. The way the iLearn test works is that it, in the first 6 problems or so, it kind of says whether, so like everybody starts at this level, and then after those first 6, you start to either get harder problems, or you start to get easier problems, or you start to get the same level problems. It's similar to NWEA in the fact that as you get more right, you'll get more difficult problems. Not to say that they will be more difficult to do. They will be appropriate for your level. So A students will probably get A level questions. D students will probably get D level questions. Now, a lot of times the question comes up, well, what if I get the harder questions, I get more wrong? Do I get a lower score than the person who got the easy questions and got more right? You do not. If you get the harder questions, they are weighted more, which means you get more credit for doing a harder question. Number 13, in my opinion, would be on the upper end of the type of the questions. This is a combine like terms question. Can I combine like terms? That's what this question's asking. And The idea behind it is it's got fractions in it, so it automatically makes it not the easiest level. The easiest level is only integers. If it had fractions and decimals, it would probably be the hardest level. So some of you guys will get more difficult questions, but you'll get more credit for them. All right, let's skip down to number 15. We're going to start skipping around in a second because we need to get through at least one of each kind. All right, so skip it down to number 15. Notice we've got parentheses floating around here. I don't like this. Anybody remember the invisible number that's in front of the second set of parentheses? There's a 1 here. So what should I do?
1 times 5x, 1 times.
So Ashley was almost right. She was like 95% right. She said 1 times 5x and 1 times negative 8.
1 times 5x.
But it's not 1. What is that? That says negative 1. So this actually is 3x minus 6 minus 5x plus 8. But Mr. Strand, this was a positive and this was a negative. Why did they switch signs? Because what's negative 1 times positive 5? Same sign, positive. Different sign, negative 5x. Negative 1 times negative 8. It's positive. Why? Because it's same sign, positive. Okay? That's a tricky question. I wanted you guys to do it. Finish that one up. Combine your like terms, finish that one up. Tell your neighbor what the answer is. And the answer was negative 2x plus 2. Let's skip to number 17. Factor 4 out of this. What does it mean to factor something? This is all first semester stuff. That's why we're getting to it. It means divide it out. Pull it out. Factor it out. It doesn't disappear. It gets factored out. All right, so 4 times what? So if I factor a 4 out of 16x, what's left? 4x. If I factor a 4 out of 24, what's left?
6.
And what's the symbol going to be? There you go. That's it. If you see factor, that's all it's saying. It's saying divide that out. Pull it out. Okay? I believe that you can do 18 on your own. Okay? And I believe that if you draw a picture for number 19, you'll be good. Let's draw the picture together. You install 404 feet of fencing along the perimeter of a rectangular yard. What shape should I draw? Good. The width of the yard is 100 feet. So what should I do? Put 100 feet on the width. What's the total length around it going to be? 404. So x and x. And I believe that you guys can solve this one the rest of your way. I want to do number 20 so you guys know what I'm looking for these. Number 20 says graph the solution of the inequality, which means we first need to solve it, right? When we graph a solution to an inequality, we graph it on a number line. So what do I need to do to both sides to get x by itself? What do I need to do? Add 4 to both sides. And I'm left with x is less than 6. So let's remember how to graph that. Who remembers what the circle or dot should be? So Lolly?
If it's filled in the circle, it means it has a line in it.
Good. So this is going to be an open circle. It's going to be at 6, 5, and 7. And now which direction does the arrow go?
Left.
Left. Why?
Because the less than.
Because it's less than. And the variable is on the left. Guys, remember how I was such a stickler about making sure the variable was on the left? Because when the variable's on the left, the arrow points the direction you're going. If you're ever unsure, just plug a number in. 7. Plug 7 in. Is 7 part of the solution? No. So you should get something that is not true. Plug 7 in, and what do you get? 7 is less than 6. True or false? That's not true, so it should not be included in the solution.
Five is.
Now you guys have about 4 minutes before you are done, and you have just a couple more to do independently. Number 23, a person jogs 1/7 mile in 1/56th hour. That seems interesting. Saeed, question? Or
Isn't the symbol supposed to switch if there's a negative?
great idea, great question. Isn't the symbol supposed to switch if there's a negative? No. Only if you're multiplying or dividing by a negative. So yes, the symbol will switch if you multiply or divide by a negative. So look at this. Is the symbol going to switch?
No.
Is the symbol going to switch?
Yes.
Is the symbol going to switch here?
Yes.
Why? There's no negative. Is the symbol going to switch here? No, because we're not multiplying or dividing by a negative. Great remembering. So what are we looking for here? Speed. What tells us what to do? What part of the question tells us what to do? Miles per hour. How many miles? How many hours? So what is this kind of problem? This is a division with fractions question. We've already done one of those, haven't we? Okay.